Example 4. Find the first and second derivative of f of x equals x to the fourth over sine x. Second derivatives tend to get really complicated really fast when we have quotients. So we're going to have to be extra careful here with all of our steps. So to begin with, let's find the first derivative. So my top function is x to the fourth, which is my f, and my bottom function is sine x, which is my g. I need to find each of their respective derivatives. The derivative of x to the fourth is 4x cubed. The derivative of sine x is cosine x. So my first derivative, I'm going to have f prime times g. So 4x cubed times sine x minus f times g prime. So x to the fourth times cosine x. All of that divided by g squared. So sine x squared. So my first derivative wasn't so bad. I was able to easily find the derivatives I needed and plug them into the formula. However, looking at this, you might start to get a sense that the second derivative is going to be a little more complicated. So again, I need to take the derivative of the first derivative. So my f is going to be the numerator. So here, my f is 4x cubed times sine x minus x to the fourth cosine x. And from there, I need to find my derivative. And then my g is going to be sine of x squared. And I need to find my g prime. So let's start by f prime. So notice that both of the terms here are going to require a product rule. So the first term, I have 4x cubed times sine x. So for my product rule, my f is 4x cubed and my g is sine x. Finding each of their respective derivatives, I get 12x squared and cosine x. So now I'm going to do f prime times g plus f times g prime. So that gives me 12x squared times sine of x plus f times g prime is 4x cubed times cosine x. But that was just the derivative of my first term. From that, I have to subtract off the derivative of the second term from x to the fourth times cosine x. So again, I'm going to have to do another product rule. So my f is x to the fourth, and my g is cosine x. My f prime is 4x cubed, and my g prime is negative sine x. So f prime times g is 4x cubed times cosine x. Now minus, because of the minus from the sine, minus x to the fourth sine x. So remember, my first derivative is this whole entire term. So now I also need to find g prime of x. Now to go from sine of x squared, and in order to take the derivative, I'm going to have to use a substitution here because I have to do a chain rule. So here I'm going to have z equals sine x, and dz dx is the derivative of sine, which is cosine. So remember, when you have parentheses to a power, the power comes down, your z stays the same, and you subtract 1 from the power. But then we have to multiply that by dz dx. So times cosine x. So now we have all the pieces we need to plug in to get our final derivative. So let's plug everything in very, very, very carefully. So again, in the top, we're going to have f prime times g minus f times g prime. So what I want you to notice about f prime is that I have a 4x cubed cosine x and a minus 4x cubed cosine x. So those are going to cancel. I'm going to use a lot of parentheses here. So I have 12x squared sine x. Now my 4x cubed cosine x terms cancel. And then this minus is also going to go to this negative term here. So that's going to cancel to give me plus x to the 4th sine x. So that's my f prime times, let me draw a line here, times g, which is sine x squared, minus, now I have to do f times g prime. So I'm going to use parentheses again because there's a whole bunch of terms. So 4x cubed sine x minus x to the 4th cos x. There's my f times g prime. So times 2 sine x times cosine x. All of that divided by g squared. So sine x squared squared. So my second derivative is really super long, right? But as long as you're careful, hopefully you won't lose any negatives or any terms. We're not going to try to simplify this because it's way too long. But again, if we go term by term and we're really careful, hopefully we don't lose anything along the way, and we're able to use the quotient rule to find our second derivative. Example 5. Find the derivative of f of x equals sine of x cubed plus 2x minus 1 over e to the 5x cubed. So this is another instance where we need to be extra careful because here our derivatives are going to involve chain rules within the quotient rule. So again, my f is always the function on top. So sine of x cubed plus 2x minus 1, and my g is e to the 5x cubed. Now, to find each of their respective derivatives, I'm going to have to do some chain rule substitution here. So for the first term, my z will be x cubed plus 2x minus 1, and my dz dx is going to be 3x squared plus 2. So remember, when you take the derivative of sine, you get cosine of z, which is the same thing. And then we have to multiply by dz dx. And I'm going to use parentheses because there's more than one term. Now over here on my e front, my z substitution, my z will be the power of e, so 5x cubed. And my dz dx, the derivative of that will be 15x squared. And with e's, the derivative is e to the z, so e to the 5x cubed, times dz dx, so times 15x squared. So now I have all my pieces that I need to find my derivative. Again, I'm going to try to be extra careful when I plug everything in. So here I'm going to start off by doing f prime times g. So cosine of x cubed plus 2x minus 1 times 3x squared plus 2. That's my f prime times g, which is e to the 5x cubed, minus f times g prime. So sine of x cubed plus 2x minus 1. That's my f times g prime, which is e to the 5x cubed times 15x squared, all divided by g squared. So we have e to the 5x cubed squared. So my derivative, with all my chain rules in there, ends up looking like this. So again, you just have to try to be extra careful, not lose any negatives, things of that sort, and plug everything in very carefully, and you should be able to find the derivative of quotients that involve chain rules.